Okay, so today we're going to talk about, starting with decimals, we're going to cover sections P4 through P6. So this is the very first chapter in your book. So decimals, so just like fractions, decimals describe part of a whole. So for an example, 20.27 is an example of a decimal number, right? So it's a decimal number, not only because we have a whole number, right? But more importantly, we have that decimal part, which is the numbers to the right of the decimal point. Okay. So just like whole numbers have names for things, we also have names for the decimal parts of things, right? So very similar to what the whole number parts are, we're going to start with tenths to the right of the decimal point, and then we're going to go to hundredths, thousandths, 10,000ths, and so on, right? So they're very similarly split up into periods, just like they are with the whole number parts. Right, so we're going to look at a few examples, and we're going to look at the place value of certain decimals. So the first one that we're going to look at is going to be 7.71. Right, so 7.71, I put it in the chart that we had above. Right, notice when we put the decimal point in this column of the decimal point, notice the underlying digits is in the tenths place. Right, so we can say that the place value of the underlying digit is going to be in the tenths place, right? And we can do very similar things with B, C, D, and E, right? So I'm going to do part B. So part B, if we insert that into this chart up here, we have 26.32, right? And notice that the underlying digit is 2, and it lines up in the hundredths place, right? So it lines up in the hundredths place. Okay, and we can do very similar things as well for the other ones, right? So let's look at part C. And what I'm going to do now is instead of inserting it into that place value chart, I'm just going to look at how many places it is to the right of the decimal place, right? So notice that it looks like it's 4 places to the right of the decimal place, right? So if we go from tenths, hundredths, thousandths, it looks like 10,000ths is the 4th number over, right? So this one has the 10,000ths place. Okay, and now I'll let you do part D and part E, and then see what you get. Okay, so hopefully you've had a chance to pause the video and try these. So part D, it looks like it's the 5th one over, right? And that means that it's going to be in the 100,000ths place. And then for the part E, it looks like it's the 3rd one over, right? So the 3rd one over is going to be the thousandths place. Okay, so let's move on and look at writing decimals in word form, and then we're going to do the flip side of that as well. So we'll start with the words and go to decimals, right? So I'm going to look at the whole number parts first. So we're going to write that just like we did in previous sections. We're going to use the word and to represent that decimal point, and then we're going to write the decimal part in words as if it was a whole number, and then we use that place values from that we did from the last page, right? So we're going to look at the first one, right? So we have 32 as our whole number. Then we use the word and for our decimal point. And then we have 47, and look at it ends in the hundredths place. So we say there's 47 hundredths, okay? For part B, it looks like we have 576. And so that and's going to represent the decimal point. And it looks like we have what, 829. 829. And then it looks like that's the thousandths place, right? So we have 829 thousandths. Okay, and then part C, notice that we actually don't have any whole number, right? It's just 0, so we don't have to write that. So what we're going to do instead is just write what the decimal place is, right? So it looks like we have 36 to the right of the decimal place. So we say 36. And then we have to know what place value that is, right? So the 4th one out is going to be 10 thousandths. So we have 36 10 thousandths. Okay. So now let's look at some ones that have words, and let's go backwards and make them into standard form, right? So on A, it looks like we have 56 and 2300ths. So we already have a solution down here, but notice that we're splitting it up into 3 parts. We're splitting it up into the whole number part, we have our decimal, and then we have all the numbers to the right of the decimal, right? So that's going to be our general solving procedure as we go through these. Okay, so let's do B over here. So for B, it says we have 300, then we have and, so that's going to be our decimal place. We have 64 thousandths, right? So thousandths is going to be our fourth decimal place, or sorry, our third decimal place over. The next one, it looks very similar, but we don't have the word and in there, right? So we have 364 thousandths. So what that means is since we don't have an and in there, we actually just don't have a whole number in the front. So C is going to start with 0 point, and then it says 364 thousandths, right? So it's still going to have the same number of decimal digits to the right as part B. Okay, and then part D says we have 15 and 46 ten thousandths, right? So we know that we're going to have 46 out here, and we know it's the 10,000, so it's going to be the fourth digit over. Okay. We can move on to looking at examples of decimals as equivalent fractions, right? So we're going to transition back and forth between decimals and words and fractions, right? So I'm going to look at writing a decimal whose whole number is 0 in an equivalent fraction, right? So what I'm going to do here is we're going to look at some of these numbers, and we're going to write each one as a mixed number, right? So what I'm going to do here is notice that we have 92 out front. So that whole number is going to stay the same even if I change it into a mixed number with fractions, right? So I'm going to have 92 out front, and notice that we have 4 tenths, and all that means is that we have 4 over 10, right? So you always want to take into consideration that place value. So the 4 tenths, tenths gives you that hint that it's going to be over 10. Again, with part B, we have 163, so that whole number will stay out front. And then notice that we have 57 thousandths. So that means we're going to have 57 over 1,000. Okay, we'll keep moving along. We're going to look at rounding decimals, right? So just like we had rounded numbers before, whole numbers, we're going to look at rounding decimals. So again, it's going to follow a very similar pattern with rounding. We're going to look at whatever it tells us to round. So whatever digit is we're rounding, I'm going to underline. We're going to look to the digit to the right. If it's 5 or above, we round the previous digit up. If it's less than 5, we round down and change all the other digits to 0 or just delete them. Okay. So let's look at part A. So part A says round 18.367 to the nearest tenth, right? So notice that the 10th place is going to be the first place to the right of the decimal, and then we're going to look to the number to the right of that. So notice that it's 5 or greater, it's actually 6. So we're going to round up to 4, and then we're going to delete all the decimals to the right of that. So 83.367 is going to round to 18.4. Okay. For B, it's going to ask us to round to the nearest hundredth, right? So that's going to be the second decimal place over. Notice to the right, it's a 4, which is less than 5. So we're going to round down. So this is going to be approximately equal to 361.87. The next one, it asks us to round to the nearest thousandth. So that's the third place value over. Notice to the right, it's 5. So we're going to round up. So this is going to be approximately equal to 1,200 and 33 hundredths. Or sorry, 328. So 328 thousandths. Okay, and then the last one asks us to round to the nearest whole number, right? So the nearest whole number is another word for the ones place, right? If we look to the number to the right, that's a 3, which is less than 5. So we're going to round down to 416. And if you want to, you can put 0.0, right? So it's about 416. Okay. The next one that we're going to look at is operations with decimals, right? So we're going to use the 4 common operations, so addition, subtraction, multiplication, and division. And we're going to do that with fractions now, or sorry, we do that with decimals now rather than fractions, right? So I'm going to look at part A. and it asks us to add these. So the way I'm going to do this is I'm going to stack them vertically, and then I can just add each of the digits together, right? So let's look at A first. So I have 15.42, and I'm going to stack it vertically with 3.5. And if I want to, I can add a 0 after that. Right? So notice that we have 2 plus 0, which is 2. 4 plus 5 is 9. This decimal place still comes down. 5 plus 3 is 8, and 1 plus 0 is 1. Right? So if we add these two together, we get 18.92. Okay, we can do something very similar for part B. So we have 6.09. We're going to add that to 28.9687. Okay. So again, we can add extra zeros if we want to, just to make it easier, right? So notice that to the very right, we have 0 plus 7, which is 7. 0 plus 8 is 8. 9 plus 6 is 15. So I'm going to write the 5 down here, and I'm going to write the 1 up top here, right? So I have 1 plus 0 plus 9, which is 10. So again, 10 ends in 0. And since we have 10, we're going to put the 1 up here again. The decimal place comes down. We have 1 plus 6 plus 8, which is 15, right? So again, I'm going to write the 5, and I have an extra 1 up here. And then 1 plus 2 is 3. So when I add these together, we're going to get 35.0587, right? So again, if you want to check your answers, you can always type this into your calculator, right? And it'll give you the same answer. Okay, let's look at a subtraction problem. So again, I'm going to set up this very similarly as far as a subtraction problem goes, right? So I'm going to set the first number up, so 163.59, and I'm going to subtract 12.36 from it. Right, so notice to the very left, or sorry, to the very right, we have 9 minus 6, which is 3, 5 minus 3, which is 2, bring the decimal place down, 3 minus 2 is 1, 6 minus 1 is 5, and 1 minus 0 is 1. So we get 151.23. Sometimes we have something where we have, we're trying to subtract something, right? But we don't have enough in the top part of the fraction, right? So in this case, like this 3, we can't subtract 8 from 3. So what we need to do is we need to borrow 1 from the digit to the left, right? So we're going to do that in one of these subtraction examples. So again, I'm going to line it up just like I usually do. 28.416, and I'm going to subtract 17.950. Okay. So notice we don't have any problems in the first row. We have 6 minus 0, which is 6. 1 minus 5, we do run into a problem. So I'm going to borrow 1 from this one. I'm going to change that to a 3. And what that is, if you kind of seen like the expanded form, that's just like 10 of the digit to the right, right? So now I have 11 here. I have 11 minus 5, which is 6. Again, we run into a problem with this one. We have 3 minus 9, which is not going to work. So I'm going to borrow 1 from the other side. So now I have 13 minus 9, and that gets us 4. Again, we'll bring the decimal place down. 7 minus 7 is 0, and 2 minus 1 is 1. So if we subtract those, we get 10.466. Okay. Multiplying decimals. When you're multiplying decimals, if you want to, you can multiply them out kind of like they show in this solution here. When you multiply them as if they were whole numbers, and then after that, you place the decimal point in the product such that the number of decimals is equal to the sum of the number of decimals in the factors. And then if necessary, you add zeros to the right of the decimal place to obtain the correct number of decimal places, right? So what I'm going to recommend doing instead is I would recommend using your calculator to be able to multiply these out. Okay, so I will do one example here where we will do the calculator. So I'll use part B for my calculator. What I would write in my calculator is I would do 0.222. I would use the multiply button, and then I would multiply that by 0.03. Right? So if we multiply those two numbers together, press the enter button, you should get 0.00666. And one thing that we can notice is that when we multiply these two things together, notice that we have 3 decimal places here, 2 here, and then we get 5 decimal places out at the end, right? For part C, I'm going to do this manually, right? So I'm going to do this manually. So if I do this, notice that we would have what? 8.57 multiplied by 64. Maybe I'll write that out here. Or maybe not. I'll just multiply it by 64. And then notice if we multiply this, we should end up with exactly 2 decimal places, right? Because we have 2 in the numerator and 0 in the denominator, right? So off the top of my head, I don't know what 857 multiplied by 64 is, right? So again, we could use the calculator for this. And if you do, you get 548.48. We can do the same thing when we're dividing, right? So whenever we're dividing something, we have 3 parts to this division problem, right? The first part is called the dividend. So that's our number to the left, right? We're dividing it by something. That's our divisor. And then what we equal to, so after we divide those two, is called our quotient, right? So very similarly, you could look at it as something like a fraction, right? You could look at it as a fraction. And if you divide that fraction, you're going to get some decimal answer, which again, we call the quotient. Okay, so we're going to do a little bit of division. So we're going to write the problem in long division. This again will come up if you decide to take the college algebra course at MTC. So I'm going to show some of these long division problems. And what we're going to do is we're always going to have these decimal places align whenever we're dividing by something. Okay, so let's look at an example. So the first one that we have is 131 divided by 5, right? So what we're going to look at first is we're going to do 5, and we're going to look at the very first place value, right? So notice that 5 doesn't go into 1 at all, right? So what we're going to do after that is look at the second decimal, or the second number, right? And we have 13 now. And notice that 5 actually goes into 13 twice, right? So we're going to do 5 times 2, and we're going to subtract out that 10. Right, so if we subtract that out, notice that we just get 3 here. We're going to slide this number 1 down, right? And then after we do that, we get 31, right? Notice that 31 is divisible by 5, right? So 5 times 6 is 30, right? Subtract 30 from 31, we get a remainder of 1. And then again, we're going to subtract or bring the 5 down, right? And then notice that 15 or 5 goes into 15 3 times. So if we subtract 15, we get a remainder of 0 at the end, right? So notice what I multiplied all these by. I multiplied 5 by 2 to get 10. I multiplied 5 by 6 to get 30. And then I multiplied 5 by 3 to get 15, right? So whatever we're multiplying that 5 by when we're subtracting numbers out is going to be what we're going to get as our final answer. So if we divide 131.5 divided by 5, we get 26. Okay, so we're going to do our own example here. We have 11.18, and we're going to divide that by 26. So again, I'm going to set it up like I'm doing long division. I put what I'm dividing inside the little bracket, right? We divide that by 26. Notice that 26 does not go into 1, right? So we can't divide 1 by 26. We can't divide 11 by 26, but we can divide 111 by 26, right? So the question is, how many times does that go into it, right? So notice that that actually goes into it 4 times, right? So it goes into it 4 times. So 4 times 26 is 104. If we have 111 subtracted from 104, we get 7, right? And notice that we can drop the 8 down after that. So we have 78. And notice that 78 divided by 26 is actually 3. So it goes into it 3 times. And it's exactly 3 times, right? So we have 78 minus 78. Notice that that results in 0, meaning that we don't have anything left to do, right? So if we divide these two numbers, we get 0.43. Okay, so let's look at the different types of decimals now. So we have 2 different types of decimals. The first type of decimal we're going to talk about is a terminating decimal. So a terminating decimal is a decimal that comes to an end, right? So some of the examples that we had talked about already were like that 0.43 that we just had, this 2.3 that we see down there. That's a terminating decimal, right? It comes to an end. But whenever we have a repeating decimal, this is a decimal that never ends. So one example that I gave was 5.232323 all and on, right? So one way that we can use notationally is we can look at the part that's repeating, right? So notice that 23 is repeating every time, and we just put a bar over it like that, right? So 0.23 with that bar just means that we have that 0.23 repeating forever. Okay, so one thing that you might see that we would have a problem with, right? We've been dividing by whole numbers. So what happens if we want to divide by something like a decimal, right? So in the case below, we have 2.3. Well, what we can do is we can just make it a whole number, right? So we can make the decimal a whole number. And how can we do that? Well, notice that whenever we're dividing two things, that's the same thing as just having a fraction, right? So we can use that fundamental principle of fractions that we have to write an equivalent fraction, right, whose denominator is a whole number, right? So notice here, 42.55 divided by 2.3, if we multiply it by 1 in a special way, so in this case 10 over 10, we get a whole number for the denominator, right? So now we're just dividing by a whole number. And we didn't change anything, right? Because all we did was just multiply by 1. We're just shifting all the decimal places over. And if you want to check that, you can check that this fraction over here, if you do that in your calculator and get a decimal answer, you're going to get the exact same answer as the right side of this equation. Okay. So what I'm going to do is I'm going to let you try the problem above, right? So we've already done some examples. So pause the video now, go ahead and try it. And when you come back, I will give you the answer. Okay, so hopefully you've tried this, and what you should get after we divide these is 18.5, right? So just a way to check your answer. Okay, so let's try doing another example here. And this one, I'm just going to do in my calculator, right? So this one, notice that we're going to divide 33.9. I'm going to put the division symbol in my calculator, and then we're going to divide that by 0.73. So if you do that, you should get 46.438, right? And what we're going to do, it asks us to round this to the nearest hundredth, right? So round the quotient or our answer to the nearest hundredth. So notice that our hundredth is our second decimal over, right? So we're going to look at the number to the right and notice that it's greater than 5, right? It's 5 or greater. It's actually 8. So we're going to round up, right? So we ended up getting 46.44. Okay. So we'll keep moving along. We're going to look at fractions and decimals at the same time now, right? So remember that fractions are just expressing division between two numbers. So if we divide by the numerator, we divide the numerator by the denominator, we're going to get a decimal, right? So this one says write 3 over 4 as a decimal. So that's the same thing as 3 divided by 4. And you can check that it's equal to 0.75, right? So we're also given that down here with this long division if you wanted to do it that way. As we get into more and more problems, you're going to definitely want to rely on your calculator to be able to calculate those answers, especially when you get some more of the complicated equations or you're dividing by really big whole numbers. Okay. So the next one we're going to look at is the decimal 2/3, or 2/3 as a fraction. We're going to write that as a decimal. So that's the same thing as 2 divided by 3, which you should get 0.66666 repeating, right? So the ... just means that it's going on and on. So if we want to show that with that bar notation that we saw earlier, we just put a 6 with a bar over it, just meaning that we're repeating that 6 forever. Okay, so we can extend this knowledge of fractions to decimals. We can extend this to not only improper fractions, but we can extend this to mixed numbers as well, right? So if we're looking at the decimal of 23 over 8, that's the same thing as 23 divided by 8, and you should get 2.875. Okay, we'll look at a few examples here. It says express each mixed number as an equivalent decimal. So what we have to do here is notice that our whole number out front, that 9, is just going to stay 9, right? It's going to be to the left of the decimal place. But the fraction to the right is going to be everything to the right of the decimal place. So whenever we're looking at these problems with mixed numbers, we really only have to calculate what 7 divided by 18 is. And we just put that to the right of the decimal place. So in this case, it's 0.38 repeating. Okay. We're also going to look at letter B for this. So letter B, notice that we're going to have a 6 here, right? Because that's our whole number to the left of the decimal place. And then if we do 9 divided by 20, you should get 0.45. So we get 6.45 as our number, or our equivalent decimal to our mixed number. Okay. So let's look at some other examples, right? So we're going to add rounding to this process. So we're going to do the same things we've already been doing, but we're going to round them this time. Right. So notice that we have 5/7. We're going to look at it in the hundredths place. That's what we're going to round to. So if we divide 5 by 7, you should get 0.714. And when we round that, it's going to be approximately equal to 0.71. Right. So how do they do that? Well, we look at our hundredths place. The number to the right is less than 5, so we round down. Okay, so let's try that with 41 over 13. So that's the same thing as 41 divided by 13, which is equal to 3.153846, right? So that's what it's approximately equal to. And what we're going to do is we're going to round that to the thousands place. So my thousands place is the third number over. If I look to the right of that, notice that we have a number that's greater than 5. So we're going to round up. So this is going to be approximately equal to 3.154. Okay, so we're going to look at this problem where we have a total cost problem, right? So we're buying two different things. We're buying 5.5 pounds of bananas at $1.86 per pound. And then we're also buying 1 3/4 pound of cherries at $2.16 a pound, right? So we want to know the total cost. So we know that if we have this 5.5 pounds of bananas, that's going to be what? As a decimal, that's going to be 5.5. And we know that we have 5.5 pounds, and we know that it's going to cost $1.86 per pound, right? So we're going to multiply that by 186. So that's going to give us our total cost for our bananas. And then we have to add that to the cost of the cherries that we buy, right? So plus, notice that 1 3/4 is the same thing as 1.75 as a decimal. And since we have, more than a pound, it's going to cost more than $2.16. And the way that we can find that is just by multiplying it by how much it costs per pound. Okay. So notice on the left, when we multiply these together, we're going to get $10.23. And on the right, when we multiply those two together, we get $3.78, right? So those are just the total cost for bananas plus the total cost for the amount of cherries that we bought. And then finally, to find the total cost, we just need to add those together. So we get $14.01.